have to say you did. It's fine. You can be quiet. I don't even care anymore. Uh, just kidding. Did you enjoy how I used the chemistry word in church yesterday on accident? That was embarrassing. We got some more food today. Appreciate that. Um, all right. So today we're going to do what we were supposed to do on Friday, but you know me, I'm not the most focused teacher. So back to page number 9, just real quick, and I'm going to leave this up right here the whole hour. Um, these are the same thing, but a lot of kids, they don't like what we're about to do. And that's fine. I get paid whether you like me or not. Just FYI, which is good in life, I've discovered. Um, but this is this is a long journey. We're going to just take a few steps on it now. But by the end of chemistry B, we're going to be hopefully pretty good at a process that's called stoichiometry. And stoichiometry is a word you've never heard of. All right. And it's Latin for super fun math with science. It's kind of weird that they had a term like that back then. But all right. So eventually, what we're going to do is I'm going to give you an amount of one chemical and ask for how much of another chemical you could make. And it doesn't seem like that bad, and it isn't. But we end up using words that are kind of confusing. So if I told you, hold on. And by the way, this is for the at the end when we're in chemistry B. But if I said, just in your kitchen, if you have 4 cups of flour, how many cookies could you make? You would need to know how much flour there was in a batch, right? And how many cookies there were in a batch, but then you could do that math. It wouldn't be that hard. We've all eaten cookies, and we've all seen flour, so we're used to it. But by the end of chemistry B, I'm going to say if you have, 25 grams of sodium acetate, how many grams of sodium chloride or whatever the equation would be can you form? So it's a little tricky, but we can do it. So be patient. At the bottom says, what is the point of this? Because I get this a lot. When am I ever going to use this crap again? Well, the process we're going to be working through the next few days is a process that you can use your entire life. Your math teachers have said that 100 times. And you're like, bull crap, I'm never going to use I in my entire life. Well, I know that. But just stick with me. All right? You can use it to convert from one thing to another. And what I mean by that is if you know the 2 ratios, you can convert something to something else. All right, even if you never use this again, it's useful to train your mind how to solve complex problems that require you to synthesize information from multiple places. And you will do that a lot, whether it's math or not. You have to take information from a lot of places and formulate ideas. So it's just good training for your brain. And then I am required by the end of the year to have covered all of these things. And so we're right here in blue. This is using mathematics and computational thinking. So all these combine for this. Now, I have a daughter of a math teacher that at least I know of. Probably some of you are way good at math. Well, I have a son of 2 math teachers. Oh, no, that's not good. Anyway, I know that some of the math we're going to do today, you know and can do in your head. I know that. But we're going to learn how to use this thing we call the picket fence with easy math so that the picket fence is easy with hard math. So just stick with me. All right. But once again, if you hate it, I get paid either way. So Merry Christmas. Now, I think Friday we just had like 10 seconds to work on these. Does that sound about right? Because I was super good at wasting time. Oh no, we're off to a rough start already. Please be a marker. All right, well, that's as good as we're going to get right now. So here we go. We were converting these probably about the time the bell rang. Is that about right, Sydney? So all we need to do for these, it says convert the following to proportions. So there's 8 ounces in a cup. So you would put 8 ounces per 1 cup. This is probably the first day the heat's been hot, and whoever designed this building put the heater and the projector in the same spot. So this fan, it's loud, and it even gets louder sometimes. So just get used to it. It will not fall and kill you. It's yet to explode, but it will someday. Anyway, I shot my laser in there one time, and it was 300 degrees inside that projector. So I don't know. Whoever thought that was a good idea to put a heater right next to the cooling inlet. Not thinkers. Okay, 8 ounces per 1 cup. Remember, it's okay if you write 1 cup per 8 ounces. You okay with that? Okay, did you already do all 4 of these? Okay, bottom 4, not too hard. For these, we just want to know what the units would be of the answer, and they're kind of weird. The unit here, how many cookies can be made from 1 bag? So it's cookies per 1 bag. If you just put bag, it's fine. You don't have to have the number 1. How many kernels of corn are in a bushel? So I'm just going to put KC for kernels of corn per 1 bushel. And then you got that. In about 15 minutes, well, I don't know, Pearson, what does the temperature say right now on the back wall? Oh, it probably has light weird on it. So it's 70. Okay, so we're about to where it realizes, oh, it's hot. About 15 minutes, you're gonna think, what just happened? It's freezing in here. It's a really cool thing for the first hour of the day. And it does the same thing right after lunch. You walk in that door, and the heat just hits you in the face. You're like, what has just gone on? And then 10 minutes later, you're freezing cold, purple hands. All right, are we okay with this? Now, I know these are odd units, but what they do, they could help me solve other questions. So like this songs per CD, and you don't need to write this down, but if I know the ratio, you know, I used to buy CDs and they were around 13 to 15 songs per CD. If I know that ratio, then someone could say, well, I have 8 CDs. And then I could quickly figure out, well, there's probably around 104. Well, if I did that right, that was stressful. There's around 104 songs then. So how would you do that? Well, you would just multiply by 8. But this is the process we're going to learn. Okay, okay. One of those days, huh? There we go. All right. So I'm going to put this little plus sign, and it's the start of what we call the picket fence. All right, and I'm going to say, all right, if I had 8 CDs, and I want to know how many songs that is, I use my proportions. I know that for every 1 CD, I have 13 songs. So I would just now take 8 times 13, and it's 104. Now this, you're like, why would you do that? You're multiplying by 8. Well, in chemistry words, things get confusing. And this is the power of this little device here called the picket fence. And it's called the picket fence because it gets a lot bigger. And it sort of looks like a fence. That's where that comes from. But here you go. Here's the power. Whoops. Whatever, I didn't need that. What we do this for is we always take what we're given, which was you have 8 CDs. You put it here. And it will always, 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 always tell you what goes down there. The CD goes down there. Because these 2 units always, 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 always have to cancel out. Go ahead. I love that you're on time and here today. Because absolutely, the next one would be songs. And let's say it was like words per song, because you wanted to know if I have 8 CDs How many words have those people been singing? And we'd have to know this like crazy. Well, on average, every song has 218 words. Now, I'm making this crap up, but it's doable based on lining the ratios up in the right way. Because if I line them up this way, songs disappear and I'm left now with words. And then you're like, well, this is crazy, kind of weird. What if I knew how many words and there was letters? So now if I knew if I had 8 CDs, how many letters there were in all of those songs. Oh, wow. I mean, we could go forever and get completely stupid, but yes, the unit here always, always, always goes down and over. And like I said, this weird example, who cares? You're multiplying by 8. But when we do chemistry with weird words, weird formulas, and weird numbers, this is an invaluable process. It helps you to keep track of math. Is anyone like me and knows how to do math, but just still suck at math? Is anyone that way? Okay, you're halfway through a problem, you know what you're doing, and you just do some little thing wrong, and that makes it all wrong. This tool will help you keep everything straight. All right. Oh yeah, I need to just work on that. Yes, ma'am. Uh-oh. How did it shut off?
It disconnected or something.
Just disconnected? Okay. Let's rescan that and hope that it works. That's a cool picture. Where's the camera? Oh, the Wi-Fi probably quit. It wouldn't be a day of teaching if everything I wanted to work worked. All right. Yep. So here we go. Just some notes. Fill these in at the bottom of page 9, and then we'll talk through it. Yes. Oh, shoot. Somewhere. Megan's still not here. Yep, thank you. James? Okay. So, just some words here. When solving problems that use proportions, it is necessary to make sure that all units cancel except for those in the answer. That's the power of this process. The picket fence is a tool used to make sure that the units cancel. When a number is on the top of the picket fence, it means the number is used to multiply other numbers by it. Okay, so just quickly, if it looks something like this, like a 5, a 7, a 2, a 1, and a 4, you multiply all the numbers on top. So you get 70, I think. And then you would divide by the numbers multiplied on bottom. We have some cans. I think they're from Kylie. Uh-oh.
And we're starting a March Madness tomorrow.
Okay, I was like, today?
So,
well,
cans every day.
Well, you can't take those cans today then. Don't take them today. No, you do not have to. Come back here, young man. These are my lunch. I was going to eat these for lunch, and then I was going to have cake for dessert. All right, see ya. Yeah, oh, you're welcome. All right. That's cheating, but as Bert says, if you ain't cheating, you're not trying. Let's see who we're going to take down real quick here. Mr. Burrell. Oh no, he's going to just bring a dead cow or something. How do we compete with that? Oh, 200 bushels of corn from Corinne. Like, well, here's our cake mix. We got this, kids. Don't make me lose to Mr. Burrell, even though I love him. Wait, which Burrell is it? Wayne W. Burrell. Brill, Burt, and Day all got buys into the second round. That is bull crap. I'm protesting by bringing food. Okay, here we go. Sorry. Multiply the ones on the top, then you divide by the ones on the bottom. All right, next. Okay, now the steps for using the picket fence are as follows. Will you fill those in? What's that? Oh yeah, this will actually be good. There is not a more whiny species than a teacher. We all have great ideas, and we know that everyone else's ideas are stupid. It's good for us. Poor Thompson, he's raised by 2 teachers. Any whining or complaining in your household? Yeah, I knew it. Okay. Are we good? Fill those in and then we'll walk through it. Now, please, 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 I know that most of these problems we're about to do, you can even do some of them in your head. Is Harding competitive? I can't remember. Oh, yeah, she is. Okay. So let's learn the process while it's easy math. So the process is easy when the math is hard. So we're going to write out proportions. We're going to see what units we want in the answer. We're going to start in the top left every single time. Tell your partner, where do we start? Always.
Top left.
Top left. And then we're going to go till we get what we want. The key is the unit on the top left always goes where? Bottom right. It always moves over 1. Okay, now. Oh, Tom Davidson. I have so many slides with E's and B's on them now. Here we go. This is not rocket science, but please help me out. Step 1, you have 23 marbles, which cost $1.79. How much do 67 marbles cost? Step number 1 is to write out proportions. It's weird, but it's right here. There's a proportion. You have 23 marbles per every $1.79. That's a proportion. It's given to me right here. How much do 567 marbles cost? So the next step was to write the unit of the answer. How much in our life? That means dollar signs. That's the unit of the answer, just money. Now, we're not going to write these out separate every single time, but we're just going to go through the process together. Can you guys see very well from over there with the way the lights are? Do you want it all dark? Who would fall asleep if it was all dark? Okay, we better not go all dark. Do you guys want an iPad too? All right. We'll just stick with it. Okay, here we go. Steps 3 and 4. So for right now, our picket fences are just plus signs. So put a plus sign right here. All right, then step 3 says, start the picket fence in the top left with what's given, or what I like to call the loaner. The loaner is the thing that's not in a proportion. So what number was not here? 567 marbles. And I can get some data from that. If I know where to start, I am just about ready to go because I know where to end. I'm ending with dollar signs. So look here. Marbles goes here. Tell your partner what else that tells you in this thing. Means what's right here? Marbles. And what number goes with marbles? There's 23 marbles per every $1.79. Now, if I look up here, what unit is canceled out? Marbles. If you have a unit on the top and a unit on the bottom, they cancel out. I'm only left with the unit of money. Is that the unit I wanted? Absolutely. Life's looking good. So math-wise, you'll all need a calculator today. You can use your phones. as long as you're not using your Snapchat calculator or your Among Us calculator. All right. So everybody type it in so I know that you know. You take 567 and multiply it by 1.79 and then divide by 23. Is this the 4415? What is it? Oh, it's so close after a year of not doing it. So if you were crazy enough to want 567 marbles at this price, you'd have to pay $44.13. Yeah, ain't no one got money for that. Okay, now. Yeah, 567 times 1.79 and divide by 23. All right, not awful. I know, you're like, I could have done that easy. But let's be honest, some of you couldn't have. I'm not looking at anybody. But you're like, oh, that was weird. Okay, here we go. Number one, Katie. Katie can earn $9 for working 2 hours. Poor kid. I need to update this for the new wages. How much would she earn for working 5.5 hours? So what's my proportion here? $9 per 2 hours. So what's my loaner? 5.5 hours. All right. Well, maybe Katie's like 11 and she's babysitting. And then that's reasonable, isn't it? Okay. And she's stoked. It's her first job. She's like, oh, I'm killing it. I'm making $4.50 an hour. Okay, here we go. So what number is not part of the proportion? 5.5 hours. Then tell your partner, please, what unit must come down here then? Don't say 2 yet. Just hours. Okay, then we would come up and find that it is 2. And 2 hours was tied to what number in my proportion? $9. That was not very good. Okay, now I'm left with hours canceling out, even though I wrote it 2 different ways. I'm left with money. Is that what I want to know? Yeah, that's the universal sign for how much would you earn. That's money. So I take 5.5, I multiply it by 9, and I divide it in half, and I get something 20. What? Sam, are you going to continue the tradition of thinking this is dumb from the Davidsons? No, all right, good. The Davidsons, I don't know like how their DNA lined up to make A+ geniuses, but it did. And they just cranked this stuff out fast. Okay, let me help you with number 3. Mr. Sanchez. This one's tricky because everything's money. But if we think about tax versus value, then they're 2 different styles of money. Does that kind of make sense? So I have it bigger on this page. Mr. Sanchez paid $345 of taxes for his lot, which was valued at $65,000. I should also update that. At the same rate, what is the value of Mr. Gomez's lot, who paid $468.75? Okay, so we're looking for the 2 numbers that would be together that make the proportion. All right, he paid that for that. That's a ratio. So I'm just going to write it here, 345. I'm going to put a money sign per 65,000. Now, I'm going to write that this was the tax and this was the value. Then they are different numbers, even though they're all money. Okay, so this would then be my loaner. Where do they go? Top left corner. So I have 468.75 tax. I want value. So tell your partner what thing must come down here. Tax. What must go up top? Value. And then I have my proportion right here. $345 of taxes for every $65,000 of value. Then I'm ready to go. You multiply the top, then divide by the bottom. Oh, look at that. Well done. Okay, well, you guys, I will give you just a couple clues, but then I want you to do the rest in the next 5 or 10 minutes. Oh, goodness. Oh, Davidson. Oh. Okay, number 2, not tricky at all. Number 3, we just did. Number 4, you need to know how tall you are in inches first. So it wants to know how tall you are in centimeters. Here's your ratio, 2.54 per 1 inch. I don't know why I put an M. Just pretend it's an N. All right, but you need to know how tall you are. So if you are 5 feet and some inches, you take 60 and add your inches. If you're 6 feet and some inches, you take 72 and add. So if I were to do this, I would say I'm 5'10", so I'd be 60 plus 10. That would be 70 inches, and that's what I would start my picket fence with. This would be my ratio. Okay, 15. This one is your proportion. It bugs kids because there's not another number, but there is. It's 14.75 money per 1 meter squared. If there isn't a number, it's 1. Okay, well, you take some time, do them by yourself first, then compare to the people around you that are awake and working, and then see if you have the right answers. We can talk after that. I mean, they're fine kids, but I just don't like them. Just kidding. That was rude. All right.
Right after you started.
I know, right when I started, I was mean. But they don't know. Okay, here we go. This is not chemistry. I am aware of that. So we're going to learn how to apply it to chemistry now on page number 11. And we're going to talk about how stupid I am that I don't remember. It's going to put an E on there when I push that button. Or a B. I wonder what this button does. Nothing. Oh, spaces. Okay. My ADD is kicking in. Let's talk about the warm and fuzzy mole. Sound good? On Friday, we talked about a mole. Will you remind your partner what a mole was? Woo. It was a big number. Is that going to be too dark? Those words are kind of small, so I thought it'd be too hard to see. Here we go. Don't fall asleep. If you fall asleep, you owe us 25 cans. Okay. Chemists have devised a means of keeping track of the amount of matter. What? Okay, there we go. Here we go. All right, matter involved in chemical reactions. This method uses the gram formula mass, better known as the molar mass, or mole for short, whatever, MOLE. In each element box in the periodic table, there are 2 numbers. Now, what we're doing right now and what we just did, they do apply to each other, I promise. The molar mass of an element is the larger of these 2 numbers. Okay, If you have your periodic table with you, will you please take it out? We are like a day and a half in the cold weather, and the skin on my knuckles is already cracking. I can't wait till January. You got that problem too, Maddie? Okay. Will all of you look open to the middle part that we haven't even looked at yet? That's what we're going to use for this lab book. In the middle section, on the far left, you will find the Na box. That is sodium, correct? All right, in the Na box, on the top, it has a 23, and on the bottom, it has an 11. For this unit, we're going to use this number every single time. And it's not always on the top on every periodic table. It's the one that's bigger. All right, let's see, on that periodic table, look at the one on the wall. It's the one that's at the bottom, but it's still the bigger one. Are we okay with that? We are going to use the bigger number in the box. Tell your partner that 3 times.
Bigger number in the box, bigger number in the box.
Bigger number in the box, bigger number in the box. Okay, so which number?
The bigger number.
The bigger number. One of my favorite students of all time, we did this, and he's like, I don't get it. And I'm like, how can you not get this? And he's like, they're the same size. Not the font, morons, the value. Now, here's the true irony of that. Guess what that kid does now? He teaches science at a junior high. And what an idiot. All right, for that choice, yes. Okay, you got to at least teach high school. Okay, so the bigger number in the box. So looking back here, for example, the molar mass of carbon. Everyone find C in the top right-ish corner and tell your partner the bigger number. 12. It is 12. Now, my friends, please, please, please. We know it's 12, but just a 12, I don't like how that looks. Did you see how that 12 is looking at me? All right, that's a little better. Just a 12 means nothing. That's a math number. 12 with some units, it becomes a science number. When you find it, it is grams per 1 mole. Now, if I said per, that means this thing is a proportion, which is really a proportion, but who cares? The molar mass of something is a proportion. And we just learned we can put proportions in picket fences. So stick with me. Now, I draw on this slate and things are kind of, they take time and they're ugly. So I save time writing like this, 12 grams per mole. Are you okay with that? That's my little divider and it's whatever. And I don't know why my O's turn into whatever that is right there. Was that like a C sharp? 8th note? I don't know. But 12 grams per mole. Okay, let's practice. Everyone together now. Find CO. It's in the middle-ish. It's cobalt. It's in the middle. And we got a what number? All right, 59 grams per 1 mole. I know that you're like, I don't want to write per 1 mole every time. Well, I don't care. Please do. It's for your own good in the long run. Okay, fire away. If you can't find copper, remember it is Cu. Strontium, Sr, krypton, Kr, in case you're lost. Okay, take a minute and do those. Oh, wow. Already done, Buns? Oh, my. Would you like to borrow one? Or you can look over your shoulder. I know. The hardest part's finding them, right? Which one are you looking for, Sydney? SR's right here. SR's on the left. And then KR will be on the far right when you get to that one. Should have made a left-handed periodic table, huh? Just kidding. Okay. Raise your hands if you need more time. And it's fine. They're hard to find. Okay. If you feel like you could find the mass of an atom given a periodic table, raise your hand. Okay, that's everybody that's awake. So I think we're all right there. So we just simply, so this was carbon. We find the big box and it's per 1 mole. Good enough. Okay, now the next part, we'll get there in a second. But what it's now going to say is, all right, well, carbon's cool, but can you find the mass of carbon dioxide? And it's not complicated, even though it's I'm going to make it more complicated. What is the mass of carbon? We just described it. It was 12 grams per 1 mole, right? Okay, looking at your periodic table, what is the mass of oxygen? Top right, 16. Are we okay with that? Okay, now look at me though. I'll come over here. Do you see that number? That 2 means that in this molecule, there's 1 carbon bonded to 2 O's. So its mass is really 1 of these plus 2 of those. Are we okay with that? So 16 times 2 is 32 plus 12 is 44 grams per 1 mole, and it would be CO2. So what we're going to talk about now for the rest of the class is, okay, we know for 1, now we just got to apply the subscripts and find the mass of everything. So that's what's next. Coming right here. It says, all right, to find out what the mass of a molecule is, remember a molecule is more than 1 atom joined together. You must first count up the different types and numbers. And I might have those backwards, but it doesn't really matter. Of atoms. Okay, so we're baby stepping this. CuSO4, if we look through it, tell your partner in CuSO4, tell your partner how many carbons, I'm an idiot, how many coppers there are. How many coppers in CuSO4? 1. If there was more than 1, there'd be a number. So I'm going to put a 1 right here. How many sulfur atoms? 1. And how many oxygen atoms? 4. That's not hard, I hope. Okay, look at the screen for 1 second. Now, it's not, but let's pretend it was CuSO4, and then I'll just teach you what to do here. If the number's outside, you just multiply everything inside by it. So it would still be 1 Cu, but now it would have been 4 S's and 4 O's. So if there's a number outside parentheses, just distribute it. Now, one other thing, if you look, what if it was S2O and then 4? You still distribute it. So partner, tell them, how many S's would there be now? There'd be 8 of them. We all right with that? Okay, there's some practice ones. And so all you're doing right here, you don't need to do much of the math. You're just telling me how much of each one of these there are. So right here, there's 2 hydrogens. Right here, there's 1 Al, 3 Co. So that's just what you're doing right there. All right, let's put this together. First off, C's, there's 6. H's, there's 12. O's, there's 6. Anyone know what this stuff is? This is sugar or glucose. All right, and then this is the only tricky one. There's Ca, and there's one of them. How many N's? N's, there's just 2. It's 2 times the 1 that's next to the N. We don't write a 1, but if there's not a number, it's a 1. And then oxygens equals 6. Okay, next, this blank is multiply. Whoops. Multiply the number of each type of atom by the molar mass of that, for example. All right, they've probably been bugging you for a while. So now we apply the CuSO4 and what we learned before. There's 1 copper and its mass is 63.5. Now, I didn't make that number up. I found it from the periodic table. You found it from the periodic table before, right? Is that right? 63.5? Okay. Next, there is 1 sulfur and it's 32 grams. And then there was 4 oxygens and they are 16. So we add all this up. Is it 159.5? 157.5? It's been a while. Did anyone already do it? It's okay. You times and add. 1 times 63 plus 1 times 32 plus 4 times 16. What did you get, Isaac? Garrett, whatever your name is. Oh, 159.5. And that's grams per 1 mole CuSO4. Oh. How about me introducing Sophie Simpson to talk yesterday too? I'm just falling apart. Here's our cool little flag. Nothing says America more than 159.5 grams per 1 mole of CuSO4, right? Ooh, we can do number 1 quick. There was 2 H's, and an H is 1 gram. 2 grams per 1 mole. I'll just keep on going. There's 1 times 27. Where'd I get that 27? Tell your partner. That's the mass of aluminum, plus 3 times 35.5. I can't remember that one. It's in the 130 area. What is it? And then here, I got this one. I know this answer is 180 in case the bell rings, but it is 6 times 12 plus 12 times 1 plus 6 times 16, and that will give you 180 grams per 1 mole. Okay, we'll do a few practice of these tomorrow to make sure they're locked in, and then we'll show you how they apply to what we were doing before with the weird math.